Good morning, my dear students. I am your ma'am, Archana Garpalli, Assistant Professor of Chemistry, Government Degree College, Bainsa and Nirmal. In the last class, we learned about alcohols. I think all of you know very well. So, what is alcohols? Yes, you are right. Hydrocarbons are hydroxy derivatives of hydrocarbons known as alcohols. So in the last class we learned about preparation of alcohols from various compounds and physical properties of alcohols, then chemical properties of alcohols and uses of alcohols. In this class, we learn about phenols and properties of phenols, physical properties and chemical properties of phenols, and various name or reactions of phenols. Phenols are aromatic hydroxy compounds. For example, phenol, 1-naphthol, cresol, that is orthocresol and metocresol, 2-naphthol or beta-naphthol. These are the examples for phenols. Then for common example in this class is phenol, that is the formula of the compound is C6H5OH. Phenol is a white color crystalline solid. It is a volatile one, and the structure of phenol is shown in the diagram. That is, phenyl group is attached to the OH group, right? Next one is preparation of phenols. So we can prepare phenol from diazonium salts of aniline. Then second one is from benzene sulfonic acid, and third one is from cumene hydroperoxide. So first one is preparation of phenol from diazonium salts of aniline. So what is aniline? Aniline is, so phenyl group is attached to the NH2 group. So aniline is treated with nitrous acid, we will get benzene diazonium chloride. So this benzene diazonium chloride on hydrolysis produces phenol and nitrogen plus HCl. From aniline to benzene diazonium chloride, reaction is known as diazotization reaction. Yes, so what is diazotization? Diazotization means preparation of benzene diazonium chloride from aniline in the presence of nitrous acid in acidic medium. So from this benzene diazonium chloride, we can prepare number of organic compounds. So for example, in this reaction, we prepared phenol. So benzene diazonium chloride, that is phenyl group, is attached to the N2 plus Cl minus on hydrolysis produces phenol plus N2 plus HCl. Next one is from benzene sulfonic acid. So benzene sulfonic acid treated with sodium hydroxide, that is NaOH, at 350 degrees centigrade produces phenol. Yes, benzene sulfonic acid is treated with sodium hydroxide at 350 degrees centigrade produces phenol. So in the reaction, benzene sulfonic acid first treated with sodium hydroxide. So we will get sodium benzene sulfonate. In the second step, after hydrolysis, we will get phenol, that is phenyl group attached with the OH group. Right. So first step is benzene sulfonic acid reacts with the sodium hydroxide, produces sodium benzene sulfonate. Right. So this sodium benzene sulfonate after hydrolysis produces phenol. Then third preparation is from cumene hydroperoxide method. So from cumene hydroperoxide method, we can prepare phenol by oxidation. Yes, on the large scale, phenol is prepared by cumene hydroperoxide. So when cumene hydroperoxide is treated with strong acids, produces phenol and acetone. Right? So cumene hydroperoxide is treated with oxygen, produces phenol and acetone, right? So in this reaction, cumene is a reactant and phenol and acetone are the products, right? We can prepare cumene from benzene. So when benzene is treated with propylene in the presence of anhydrous aluminium trichloride, so it produces isopropyl benzene, that is cumene. So cumene also known as isopropyl benzene. So this isopropyl benzene or cumene is reacts with the oxygen or acids, produces cumene hydroperoxide. So this cumene hydroperoxide undergoes rearrangement type of reaction. So after rearrangement, it produces phenol and acetone, right? So next one is the properties of phenol. So we have two types of properties, that is physical properties and chemical properties. So first one is physical properties of phenol. So first one is most of the phenols are colorless liquids or solids. So although they are often found to contain a red tint owing to the presence of oxidation products. Then second one is phenols have a characteristic carbolic odor. Then third one is the boiling points of phenols are higher than aliphatic alcohols of comparable molecular weights. So this is due to stronger intramolecular hydrogen bonding in phenols relative to alcohols. For example, the boiling point of phenol is 182 degrees centigrade, while cyclohexanol is 162 degrees centigrade. So what is the reason? Because of hydrogen bonding, phenol having higher boiling point than the cyclohexanol, right? So what is hydrogen bond or hydrogen bonding? So hydrogen bonding is a partial intermolecular attraction force between hydrogen and highly electronegative atoms like nitrogen, oxygen, fluorine and chlorine. So in the last class we learned about hydrogen bonding. So we know hydrogen bonding is two types, that is intermolecular hydrogen bonding and intramolecular hydrogen bonding. So what is intermolecular hydrogen bonding? So intermolecular hydrogen bonding is between two various molecules, like two phenols or one phenol and one water molecule. So between two molecules. If the hydrogen bond is formed, it is known as intermolecular hydrogen bonding. Then what is intramolecular hydrogen bonding? So within the molecule only. Within the molecule, if hydrogen bond is formed, so then it is known as intramolecular hydrogen bonding. Right? Undergoes intermolecular hydrogen bonding. So phenol itself is sparingly soluble in water, but polyhydric phenols and para-substituted phenols are soluble in water owing to the hydrogen bond formation with the water molecule. The observed physical properties, high melting point and high boiling point and solubility in water, are mainly due to the hydrogen bonding presence in between and within the molecules. Next one is chemical properties of phenol. So, chemical properties of phenols studied under three categories. That is, number one is reactions involving the cleavage of OH bond, and second one is reactions involving the cleavage of CO bond, and third one is reactions involving aryl and hydroxyl group. So there are three types of chemical properties, that is OH bond cleavage, second one is CO bond cleavage, and third one is aryl and hydroxyl group involving chemical reactions. The first one is reactions involving the cleavage of OH bond. So it explains the acidic nature of phenol. So first one is acidic nature of phenol. So acidic nature of phenol can be explained on the basis of resonance structure of phenol. So you see the resonance structures of phenol. So in this resonance structure, the lone pair of electrons of oxygen involving in resonance with aromatic ring. Actually, oxygen is a electronegative atom. So this electronegative atom is carrying or acquiring positive charge. So it attracts the bond pair of OH bond more towards itself, thereby facilitates the release of H plus ion in basic medium. So in the basic medium, phenol forms phenoxide ion. So this phenoxide ion is very stable. So why? Because it's stabilized by the resonance structure. You can see the resonance structures of phenoxide ion in the next slide. So resonance structure with the separation of opposite charges are more energetic and less stable. So in phenol we have two charges, that is positive and negative one. So phenol resonance structures are high energetic and less stable, while phenoxide ion resonance structures are more stable. So why? Because here we have only one charge, that is only negative charge is there. And in phenoxide, so oxygen also carrying negative charge, which is a electronegative one. So that's why it is very stable. So phenol resonance structures are high energetic and less stable, and phenoxide ion resonance structures are more stable and less energetic. So that's why phenol is weak acidic in nature. So phenol loses one H plus ion and forms phenoxide ion, which is a stable one. So this stable phenoxide ion undergoes resonance. So it is a resonance stabilized one and more stable, less energetic one. So that's why phenol exhibit acidic nature. And the other alcohols are neutral. The formation of alkoxide is not possible easily since it is not stabilized by resonance, and in fact plus I effect of alkyl groups destabilize it by increasing electron density. So phenols are acidic and alcohols are neutral one, right? And the next one is reactions of phenols. So phenol reacts with the sodium metal and form sodium phenoxide. Phenol also reacts with strong bases like sodium hydroxide to form sodium phenoxide plus water. It is a neutralization reaction. So phenol is a weak acid and sodium hydroxide is strong base. So weak acid plus strong base gives rise to sodium phenoxide. So sodium phenoxide is a salt plus water. So it is a neutralization reaction. So second reaction is reaction with RX. RX is nothing but any alkyl halide. R is equal to alkyl group and X is equal to halogen group. That is, X is nothing but fluorine, chlorine, bromine or iodine. Right? Phenol reacts with methyl chloride in the presence of anhydrous AlCl3 or aluminium trichloride to form paracresol as main product and orthocresol is small product. So you see the reaction. This is a phenol. Phenol is reacted with methyl chloride, that is CH3Cl, in the presence of anhydrous AlCl3. So to form paracresol. So paracresol is parahydroxytoluene and it is a main product. And second product is orthocresol, that is orthohydroxytoluene. Right. Next, third reaction is electrophilic substitution reactions of phenol. So phenol undergoes different types of electrophilic substitution reactions. That is, number 1 is nitration, number 2 is sulfonation, number 3 is halogenation. Right. So what is electrophilic substitution reactions? So electrophilic substitution reaction means an electrophile is substituting on the benzene ring, right? So here the phenols undergoes electrophilic substitution reactions because phenol is a electron rich group. What is the electrophile? Electrophile is nothing but the electron deficient species or electron attracting species known as electrophile, right? So these electrophiles are two types. We have positive electrophiles, neutral electrophiles. Examples for electrophiles are Cl plus, Br plus, I plus, H plus, NO2 plus, SO3, etc. In this electrophilic substitution reactions, so first one is nitration reaction. So in the nitration, phenol reacts with 20% of nitric acid to form orthonitro and paranitrophenol. So phenol reacts with 20% of nitric acid and forms orthonitrophenol and paranitrophenol. Yes, you see the reaction. So phenol, in the presence of nitric acid, 20% nitric acid, it forms orthonitrophenol and paranitrophenol, right? So in the nitration, NO2 plus is the electrophile, and in orthonitrophenol we have possibility of intramolecular hydrogen bonding, right? Second type of electrophilic substitution reaction is halogenation reaction. So phenol undergoes halogenation reaction with bromine. In this, we have two types of halogenation reaction. In first one is phenol is treated with aqueous solution of bromine, undergoes bromination very rapidly to form 2,4,6 tribromophenol. Right. So phenol reacts with bromine water, which is a red color one. It produces 2,4,6 tribromophenol, which is in white color precipitate. Right. Then second one is phenol reacts with the bromine in the presence of carbon disulfide at 0 degrees centigrade to form orthobromophenol and parabromophenol. In the presence of polar solvent, the bromination reaction rapidly taking place. But in the presence of non-polar solvents like carbon tetrachloride or carbon disulfide, it produces only monobromination, that is orthobromophenol or parabromophenol, right? Because of the high reactivity of benzene ring, catalyst or halogen carrier is not required for bromination. Tribromination in aqueous solvents takes place because of the fact that water facilitates the ionization of phenol to phenoxide ion, which is more reactive than phenol towards electrophilic substitution. Third one is sulfonation. So phenol reacts with sulfuric acid to form orthohydroxy benzene sulfonic acid and parahydroxy benzene sulfonic acid. You see in the reaction, so phenol reacts with sulfuric acid to form orthohydroxy benzene sulfonic acid and parahydroxy benzene sulfonic acid. Yes, third type of reactions are reactions involving aromatic ring and OH group. So in this we have number of Nemer reactions. So in this first one is Riemann-Tiemann reaction. So Riemann-Tiemann reaction. So what is Riemann-Tiemann reaction? So Riemann-Tiemann reaction is when phenol is treated with chloroform in the presence of sodium hydroxide or potassium hydroxide, which is a base, an aldehyde group, that is CH4 group, is generally introduced in the ortho position. So this reaction is known as Reamer-Tiemann reaction. So Reamer-Tiemann reaction is when phenols are treated with chloroform in the presence of base like sodium hydroxide or potassium hydroxide to produce ortho hydroxybenzaldehyde and para-hydroxybenzaldehyde. So we will see the mechanism. So in this mechanism we have 3 steps. So in the first step, chloroform reacts with potassium hydroxide and forms a electrophile is CCl2 dichlorocarbene, which is a neutral electrophile. So in the second step, the neutral electrophile attacks on the phenoxide ion and substituted at ortho position. So in third step is removal of H plus ion. So by this removal of H plus ion, we will get ortho-hydroxybenzaldehyde. And the next reaction is Gautermann-Koch reaction. So Gautermann-Koch reaction is a preparation of aromatic aldehydes by the treatment of aromatic compounds with carbon monoxide and HCl in the presence of AlCl3 and cuprous chloride. So in this reaction, phenol reacts with CO plus HCl in the presence of AlCl3 to form para-hydroxybenzaldehyde. This reaction, CO and HCl behave like the hypothetical formyl chloride. So this reaction is known as Gautermann-Koch reaction. So what is Gautermann-Koch reaction? The Gautermann-Koch reaction is preparation of aromatic aldehydes from CO plus HCl in the presence of AlCl3. Next one is the azocoupling reaction. An azocoupling reaction is an organic reaction between diazonium compound and aromatic compound that produces azo compound. So here phenol reacts with benzene diazonium chloride and forms phenol benzene diazonium adductive. So here phenol plus benzene diazonium chloride gives rise to benzene diazonium and phenol adduct. It is known as azocoupling reaction. Yes. So azocoupling reaction is nothing but an organic reaction between diazonium compound and aromatic compound. Produces azo compound. Azo means N double bond N. And next reaction is Shortbowmen reaction. So in this reaction, phenol reacts with sodium hydroxide and forms sodium phenoxide ion. This sodium phenoxide ion reacts with acid chlorides and to form esters. So this type of reaction is known as Shortbowmen reaction. So what is Shortbowmen reaction? Phenols reacts with acid chlorides to form esters. This type of reaction is known as Shortbowmen reaction. So in the reaction, phenol plus NaOH gives rise to sodium phenoxide. So this sodium phenoxide reacts with benzyl chloride So it forms ester. Reaction is known as Shortbowmen reaction. The next one is the Hobenhodge reaction. So these are very important reactions. All neighbor reactions are very important. So remember all these reactions. So Hobenhodge reaction. Phenol reacts with nitrile to form para-hydroxy-acetophenone. Phenol reacts with nitrile to form para-hydroxy-acetophenone. So this reaction is known as Hobenhodge reaction. So in this reaction is type of Friedel-Crafts acylation with hydrogen chloride and a Lewis acid. And final reaction is reaction with FeCl3. Phenols reacts with FeCl3 to form violet color complex. This is the identification test for phenol. So phenol reacts with ferric chloride, that is FeCl3, to form violet color complex. So this is the identification test for the phenol. We can identify the phenol by this test. So in this class we learn about preparation of phenol. So we have preparation of phenol, 3 preparation methods. Number 1 is from diazonium salts of aniline, and second one is from benzene sulfonic acid, and third one is from cumin hydroperoxide. And we learned physical properties of phenol. So phenol is a weak acid. It is sparingly soluble in water and it forms hydrogen bonding with the water molecule. Due to hydrogen bonding, the solubility and boiling points and melting points are higher than the other molecules. Then chemical reactions of phenols. So in this chemical reactions we learned acidic property of phenol and electrophilic substitution reactions of phenol, that is nitration, halogenation and sulfonation, and various Nemer reactions, Riemel-Tiemer reaction, Gattermann-Koch reaction, azocoupling reaction, Shortbowmen reaction and Hobenhodge reaction, and reaction with FeCl3. So with this we completed phenol chapter, right? So thank you one and all. Write down the notes. So we will meet tomorrow by another video lesson. Don't go unnecessarily outside. Stay home, stay safe. Bye-bye. Your chemistry madam, Archana Garpelli. Thank you.